In the previous lesson, we learned about numeric data types. The next data type we need to learn is called char. The word char is short for character and refers typically to characters of text. Characters of text usually occupy 1 byte per character. 1 byte is 8 bits. Although there are some architectures for which that may not be true, I want you to remember that 1 byte is 8 bits. So let's imagine that I say this. So with this printf statement, we know that somehow A is being encoded in binary, but exactly how? The answer is that there is a table of binary values for every character on your keyboard. We are going to explore that in this lesson. One such table that many C compilers use is the ASCII table, ASCII. The ASCII table is simply a table of many different characters which can be represented in a single byte. All of the letters on your keyboard, assuming you have a US layout keyboard, are ASCII characters. First, understand that every char data type occupies exactly 1 byte in memory. The data type char has a fixed size of 1 byte. In this lesson, and throughout the course, we will be assuming that 1 byte is 8 bits, or 8 binary digits. As I stated above, this is not 100% universal, and I encourage you to keep that in mind. If we consider a byte as 8 binary digits, you should be able to answer the question, therefore, how many possible values can fit in 1 byte, and consequently, how many possible ASCII character codes can there be? So here is an example of some letters in ASCII and how they are represented in binary. Now let's take a look at the first one, which is the letter A. So the way you represent A in binary, and don't worry, you won't have to memorize this, but the way you do it is 01000001, which if you were representing that value in hexadecimal, this is 4 and this is 1, so it would be 41 in hexadecimal. Remember, these values are all hexadecimal. So B is 42, C is 43, and finally you go all the way through to Z. Now this is not hard to remember. In fact, if you do memorize just A as being 41, you can figure out any other capital letter because it's going to be 41 plus whatever letter of the alphabet it is. So all you have to remember are these 3 things. First of all, every ASCII letter has exactly 8 bits, which is 1 byte. Secondly, all capital letters will always begin with 0, 1, 0 in binary. And finally, the last 5 bits start at 1 and work their way up to 26. So the character Z is 5A, which is right here. Now take a look. The 010 indicates that this is a capital letter, and then this is the number in the alphabet that corresponds to the letter Z if you start at A is 1, B is 2, C is 3, and so on. Now let's take a look at lowercase letters. So for lowercase letters, you'll notice that the first 3 bits are not 010 like they were for capital letters, but rather they are 011. So immediately you should be able to recognize an example of a binary flag. When you are comparing capital letters to lowercase letters, this 3rd bit is a flag that indicates whether or not the letter is capital or lowercase. So for lowercase letters, rather than starting at 01000001, which is 41, we start at 61 in hexadecimal, which is lowercase a, and we work all the way down to 26, which is Z. So keep in mind that the third bit in a binary representation of an ASCII letter is a flag that indicates whether or not the letter is capital or lowercase. This means that if you have a capital letter, you can make it lowercase by turning that flag on or setting it to a 1. If you have a lowercase letter, you can make it into a capital letter by turning that flag off or setting it to a 0. For right now, just memorize this. Capital letters begin with 010, lowercase letters begin with 011, and the last 5 bits start at 1 for A, and 2 for B, 3 for C, all the way to 26 for Z. Remember that ASCII is only one way that you can encode text characters. We will learn about other methods throughout this course. Also, remember that C is not required to use ASCII for encoding. The specifics concerning this are beyond the scope of this lesson and will be discussed in greater detail later in this course.